A powerboat and a raft boat left Dock A on a river and headed downstream. This is Dock A right here. The raft drifted at the speed of the river current. So the raft doesn't have an electrical motor to get it to go from point A to point B, or in this case, Dock A to Dock B. Rather, it's just going to travel with the speed of the river, because this is going downstream right here. So the river will travel down and the raft will travel at that speed. The powerboat maintained a constant speed with respect to the river. The powerboat reached Dock B downriver, then immediately turned and traveled back upriver. Eventually, it met the raft on the river 9 hours after leaving Dock A. And how many hours did it take the powerboat to go from A to B? And by the way, this is the 2011 AMC 12A problem number 12. So keep in mind that the powerboat doesn't just follow the speed of the river current. It's actually going at a constant speed from A to B and then traveling from B to A, because the powerboat has a motor, an electric motor, that can allow it to go at a certain speed. So how would we solve something like this? Well, there's actually kind of a secret to this problem, and that lies in the idea that the speed of the river current is something we can decide. Keep in mind, it just said the raft drifted at the speed of the river current. Nowhere did it actually say what the speed of the river current is. The only number in here is this 9 hours. So we can actually pick what the speed of the river current is. So if the raft drifted at the speed of the river current, well, how about we just say the speed of, we'll just write the speed of the river current as S and river current as subscripts, is equal to 0. What if we just say that the raft actually doesn't travel at all? It says it drifts at the speed of the river current, but if we set the river current speed at 0, then the raft doesn't drift anywhere. So technically it just stays at point A, doesn't actually move down to point B. And that greatly helps with this problem actually. If the raft was staying at point A the whole time, then that technically means the powerboat took 9 hours to go from point A to point B and from point B to point A, because that's when the powerboat is going to meet the raft again at point A. So again, the powerboat took 9 hours to go from here to here and then back from here to here. Now how does that help us? Well, the powerboat maintained a constant speed with respect to the river. The powerboat's speed does not change. So when it goes from A to B and then from B to A, it's going to have the same exact speed. So therefore, if it took 9 hours to go from A to B and then from B to A, and it's a constant speed, then for it to just go from A to B, which is what the question is asking, how many hours did it take the powerboat to go from A to B, then it would just be 9 divided by 2, because the total distance traveled is A to B and B to A. So basically twice the distance from A to B. And the question is asking how many hours did it take to travel from A to B, just A to B. So if we use d equals rt, distance equals r times t, if we called A to B, the distance between A to B, as x, then we can say that 2x, so basically the powerboat went from A to B and then B to A, so 2x equals the rate, which we can just call as r, we can just leave as r, and then the time, which in this case is 9 hours. However, we want the time that takes to travel from A to B, so just x, not 2x. So if we divide both sides by 2, we get r times 9 divided by 2. We don't affect this r because again, it's a constant speed. The r does not change. However, the time can change, so therefore it takes 9 divided by 2 hours for the powerboat to go from A to B, or in other words, 4.5 hours. Circle this, and we are done.